Hello everyone, welcome to chemistry classes. So in the yesterday class we have discussed about what are metallic conductors and what are ionic conductors or electrolytic conductors, okay, and what are the properties of those conductors and the factors which can change or which can affect the conductance of metallic as well as electrolytic conductors. Okay, so now we'll discuss the most important bit, that is the measurement of conductivity of ionic solution. So now we are going to discuss about the measurement of conductivity of ionic solution. The measurement of conductivity of ionic solution, and as already we know that the conductivity is best measured. We cannot measure conductivity directly, but it can be best measured or best determined by identifying or by measuring the resistance of a material, isn't it? So to get the value of conductivity, first we go for the determination of resistance of a material. So we should identify the resistance of a material. By that, by using some formulae, we can convert that resistance into the value of resistance into our conductance. Okay, and we'll discuss about this thing. And we know that the unknown resistance is determined by Wheatstone bridge. So I think we have learned in your physics as well as physics. In physics we have learned about Wheatstone bridge. So what is the use of Wheatstone bridge? So for which purpose we use Wheatstone bridge? Do you remember? We use Wheatstone bridge to calculate or to measure the resistance of unknown resistor, the resistance of unknown material. If I take this as my material, if I want to determine the resistance of this material, so I should join this material to Wheatstone bridge, then I can calculate the resistance of this material, isn't it? So the unknown resistance is determined by Wheatstone bridge. So here also now what we are going to measure? We are going to measure the conductivity of ionic solution. To measure conductivity, we should calculate the resistance of ionic solution. So the unknown resistance is determined by Wheatstone bridge. By using Wheatstone bridge, we should calculate the resistance of ionic solution. So here, for the measurement of resistance of an ionic solution, there are two problems. To measure the resistance of ionic solution by using Wheatstone bridge, we come across two major problems. These are very much major problems. So the very first problem is on passing DC. DC means what? Direct current. On passing direct current, it will convert composition, or it will convert or change the composition of the electrolytic solution. So on passing DC current to the electrolytic solution, the composition of the electrolytic solution changes. So about this we have learned in our electrolytic cell. Do you remember? So in electrolytic cell we take a electrolytic solution. So in that we dip two electrodes. On passing electric current, what happens? On passing electric current, non-spontaneous chemical reaction takes place. So as non-spontaneous chemical reaction occurs, the composition of the solution changes. So on passing DC current, the composition of electrolyte changes. So this is the biggest problem. If I want to calculate the resistance of some solution on passing direct current, why I have to pass direct current? To measure resistance by Wheatstone bridge, I have to pass the direct current. If I pass direct current, the composition changes. If the composition is changed, the value is not a value of electrolyte, the resistance of our electrolyte. So this is first problem. On passing DC current, the composition of electrolyte changes. To avoid this, we have a solution. There is solution. So please remember, for each and every problem there is a solution. There must be a solution. So calmly we have to wait for the solution. We have to find the solution. That solution is nothing but, instead of using DC current, it is better to use AC current. If I use alternate current in the place of direct current, now the alternate current do not change composition. Problem solved. So if DC is used, our composition changes. In the place of DC, if I use AC current or AC source, what happens? On passing AC source, there will be no change in the composition of the electrolyte. So the first problem is solved. First problem solved. Let us go for second problem. So what's my second problem? See here. In Wheatstone bridge, if I want to calculate resistance of this material, this is solid. So what I have to do? So let us add this terminal to this end and this terminal to this end. I will join this material to the Wheatstone bridge. Then I can calculate the resistance of this by balancing the Wheatstone bridge. Then here comes a real problem. It is the solution cannot be connected to the bridge like a metallic wire. See here, what we are going to measure? We are going to measure conductivity of ionic solution, or by using Wheatstone bridge we are going to measure resistance of ionic solution. Solution means it's a liquid, so we cannot connect liquid like a wire. Wire is solid, so I cannot connect liquid to this ends. So these terminals cannot be connected by liquid. Then how to solve this? So I want to measure the resistance of liquid. I have a solution for what? For solids. To measure the resistance of solids, I have my Wheatstone bridge. By using the very same Wheatstone bridge, I want to calculate resistance of solution, electrolytic solution. But the problem is I cannot connect this electrolytic solution, the electrolytic solution like a wire. And how to solve this problem? Yes, for this problem also there is a solution. So that solution is none other than we will design a new type of vessels. The new type of vessels, those vessels are specially designed for the measurement of their resistance. The measurement of resistance by using Wheatstone bridge. Those vessels are called as conductivity cells. Those are nothing but they are called by the name conductivity cell. Those are called as conductivity cell. So this is a typical example of conductivity cell. This is an example of a conductivity cell. So here the conductivity cells are made like this. So these cells are inserted with two electrodes. See here, this is also an electrode, the platinum electrode coated with platinum black. So do you remember the platinum electrode coated with platinum black? It is used as inert electrode. Previously we have used the platinum electrode where? Yes, in case of standard hydrogen electrode. So in the very same manner, we are adding two electrodes. This is also platinum electrode. This is also platinum electrode. These two electrodes, the surface of those electrodes are finely, so they are pasted with finely divided platinum or platinum black. So these two electrodes behave as a terminal. These two electrodes behave as a terminal, and these two electrodes can be connected to my Wheatstone bridge. See here, I can connect them to my Wheatstone bridge. See here, this end is connected with this and this end is connected here. Problem solved. So now my solution is connected to Wheatstone bridge. See here, these two electrodes are separated by distance L. The length between these two electrodes is L. So what is this? The separation between electrode. The separation between electrodes. And these two electrodes have area of cross section A. It means what? Area of cross section. The area of cross section. So these two electrodes are separated by distance L and they are having area of cross section A. Means what? If a solution confined between these two electrodes, the solution present in between these two electrodes behave like a column of length L and area of cross section A. See here, the solution present between these two electrodes behave as a column of length L and area of cross section A. So by using these data we can calculate important physical quantity. The important quantity of this, that is cell constant. We can calculate cell constant. So cell constant is symbolized as G star. As already we know that cell constant. So it is measured in the units of per centimeter or per meter. Okay. So cell constant. So what is cell constant? G star is equals to L divided by A. G star is equals to L divided by A. But there is also a problem. So the problem is, see here, this problem is, it's such a major problem. This problem is nothing but it is inconvenient to measure cell constant for each and every cell. For each and every cell we cannot measure cell constant. It is not only inconvenient, it is unreliable too. So because of that reason, what we do, we find a solution for this also. There is a way for this also. So we use a standard cell constant values. The standard cell constant values. See here, the cell constant is usually determined by measuring the resistance of the cell containing solution whose conductivity is already known. See here, it is inconvenient to measure these two values L by A. So it is inconvenient to measure cell constant. To avoid this problem, what we do, we take a cell constant is usually determined by measuring the resistance of the cell. We'll determine resistance of the cell. The cell should be filled with a solution whose conductivity is already known. See here, in this solution, in this cell, I have taken a solution. I must know the conductivity of this solution. If I know the conductivity of this solution, I can calibrate this cell with the cell constant standard value. To get this standard value, I can calibrate this cell conductivity cell. So the cell constant is determined by measuring the resistance of the cell which containing solution whose conductivity is already known. So here ಈ ಸೆಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂನ ಮೆಜರ್ ಮಾಡೋದು ಅಷ್ಟು ಈಸಿ ಇರೋದಿಲ್ಲ, ಹೌದಾ? ಸೊ ಇಟ್ ಈಸ್ ಹೈಲಿ ಇನ್ಕನ್ವೀನಿಯಂಟ್. ಇದು ಇನ್ಕನ್ವೀನಿಯಂಟ್ ಆಗೋ ಸಲುವಾಗಿ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ನಾವು ಈ ಸೆಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಗಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ ಯಾವುದೋ ಒಂದು ಕಂಡಕ್ಟಿವಿಟಿ ಸೆಲ್ ಅನ್ನು ತಗೋತೀವಿ, ಅದರಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಹಾಕ್ತೀವಿ. ಬಟ್ ಆ ಸೊಲ್ಯೂಷನ್ ಹೆಂಗಿರಬೇಕು ಅಂದ್ರೆ ಆ ಸೊಲ್ಯೂಷನ್ ಕಂಡಕ್ಟಿವಿಟಿ ನಮ್ಗೆ ಏನಿರಬೇಕು ಆಲ್ರೆಡಿ ಗೊತ್ತಿರಬೇಕು, ಹೌದಾ? ಸಪೋಸ್ ನಮ್ಗೆ ಕಂಡಕ್ಟಿವಿಟಿ ಗೊತ್ತಿತ್ತು ಅಂತಂದ್ರೆ ನಾವ್ ಏನ್ ಮಾಡ್ಬೋದು, ಆ ಕಂಡಕ್ಟಿವಿಟಿ ಮತ್ತು ರೆಸಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಸೆಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂನ ಬರೀಬಹುದು, ಹೌದಾ? ಸೊ ಅದಕ್ಕಾಗಿ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ನಾವು ವಿ ಯೂಸ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೊಲ್ಯೂಷನ್. ಅದಕ್ಕಾಗಿ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೊಲ್ಯೂಷನ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಹೌದಾ? ಫಾರ್ ದಿಸ್ ಪರ್ಪಸ್ ವಿ ಯೂಸ್ KCl solution. The standard solution is nothing but KCl solution. For this purpose we use KCl solution. See here, the conductivity of KCl solutions at different concentrations are given, they are known. So for example, I give conductivity of 0.1 m KCl. 0.1 m means what? 0.1 mole per liter. 0.1 m means what? Molarity of 0.1 m. 0.1 m solution means what? 0.1 mole per liter KCl solution. Conductivity of this solution is equals to 0.0129 Siemens per centimeter. 0.0129 Siemens per centimeter. If it is expressed in terms of centimeter, if the very same value is expressed in terms of meter, it becomes 1.29 Siemens per meter, because 1 meter is equal to 100 centimeters, isn't it? So because of that reason, the standard value of cell constant is 1.29 Siemens per meter when the concentration of KCl solution is 0.1 m. See here, cell constant is equals to L by A, and it is also calculated as R into kappa. So kappa is already known. Kappa is already known. To measure cell constant, what I need kappa value. Kappa is already known, and I should calculate which value? I should calculate the value of R. The value of R is calculated by which process? I can calculate the value of R, resistance. So the value of resistance can be calculated by using Wheatstone bridge. By using Wheatstone bridge, I can calculate value of R. If value of R is calculated, determined, the K is already, kappa is already given. So the product of these two will give the cell constant. By using cell constant, I can calculate the conductivity of any cell. Okay. So this value is constant. Please remember, in problems, numerical problems, if you are given, if you are said to calculate the conductivity, then we have to use the G star value. We have to calculate G star value. If you have to calculate resistance or another parameters, the conductivity is given, or otherwise they will conductivity of this solution. By using this, you have to calculate conductivity of a given solution. So this is used as a standard. So now we have determined the value of conductivity is given. We have determined the value of R. The value of R is determined by using Wheatstone bridge. Wheatstone bridge. Once the cell constant is known, the resistance is measured by Wheatstone's bridge. Wheatstone bridge. See here, in Wheatstone bridge, how to measure resistance? We will see how to measure resistance. See here, in Wheatstone's bridge, the circuit is joined like this: R1, R4, R3. These three are the resistors. These three are the resistors whose resistance is known. Whose resistance is known. I know the value of resistance of R4, resistance of R3, resistance of R1. Here generally I use R1 as a variable resistance. Here R1 is a variable resistance. For variable resistance I use rheostat. In our lab we use rheostat because on changing the value of resistance of R1 I can balance this bridge. Okay. At R2, this R2 is taken as unknown resistance. Here the resistance of R2 we have to measure. Now we have to measure the resistance of this R2. So for this I want to measure the resistance of this solution. So I will connect my conductivity cell at this position. So this R2 is unknown resistance. Now I have to calculate resistance of this cell. So this cell is the resistance of this solution. So this cell is connected here like this. This terminal is connected with one terminal and another terminal is connected with another electrode. So here this P is known as detector. This P is a detector, and this Wheatstone's bridge is fed with the frequency of AC source. Here this is AC source. This O is AC source. Here the given frequency is 550 to 5000 oscillations per second or cycles per second. 550 to 5000 cycles per second or hertz. See here, 550 to 5000 hertz is nothing but this is audio frequency range. This is audio frequency range, means we cannot use DC current now in this Wheatstone bridge. We cannot use DC current. Why? If I use DC current, what happens? The composition changes. So because of that reason I am using AC source. So this AC source provides the frequency of this much range, 550 to 5000 hertz. So this is nothing but audio frequency range. That is nothing but audio frequency range. Here, if this is audio frequency range, it can be detected easily by using headphones, isn't it? Audio frequency means what? It is audible, means so this frequency here detector we can use even headphones or other electrical devices which can detect the sound. Here I will use headphones. See here what should happen, how to balance this. See here, if this current is passing in the network, the current is passing in this network, in these two junctions, if current is passing, then what happens? Here I can get some noise. Then what I have to do? I have to change the resistance of this R1. The resistance of R1. So at which point the noise stops? At which point the noise stops? That is nothing but at that point my Wheatstone bridge is balanced. That Wheatstone bridge is said to be balanced. So I will goes on increasing the resistance of R1. At some point what happens? The noise stops. At that point the Wheatstone bridge is said to be balanced. If the Wheatstone bridge is balanced, then what happens? R1 by R2 is equals to R3 by R4. R1 by R2 is equals to R3 by R4. This half part is balanced by another half part. the ratio of R1 by R2 is equals to R3 by R4. So I know the value of R4, I know the value of R3, and also I know the value of R1. If three values are given, it is easy to calculate the fourth one. So I can calculate unknown resistance R2. This R2 is equals to R1 R4 divided by R3. By changing this equation, R2 goes at this point, here R1, R4 comes here, R1 into R4, then R3 comes to denominator. So R2 is equals to R1 R4 divided by R3. So by this I can calculate. So now I have calculated the value of unknown resistance. The unknown resistance is nothing but the resistance of my electrolyte solution. The resistance of electrolyte solution. If the resistance of electrolyte solution is known, and already by this we know the conductivity, and if the resistance is known, here we know the cell constant. By using the value of resistance and cell constant, it is very much easy to calculate the value of conductivity. So what is the formula? Conductivity of the solution is equals to kappa is equals to G star divided by R. G star means what? Cell constant. R means what? Resistance. So this cell constant is determined by using KCl solution, and R is determined by using Wheatstone bridge. So by this method we can calculate or we can measure the conductivity of ionic solution. So this is about the measurement of conductivity of ionic solution. I hope all of you understood about this. If you find this video is helpful, please like, comment and share among your friends, and please don't forget to subscribe. Okay, thank you so much for watching.